This is the Honda case study, question number 2. The lead time of a process, also known as the flow time, is the time it takes for a motorcycle to be built from start to finish. Or in a service system, it's the time for a customer to be processed from start to finish in a process, assuming there's no delays, no backlogs. In this case, looking at the process flow diagram, we see that there are 4 subassemblies that need to each get finished, send the parts to final assembly, and then final assembly do the 30-minute building of the motorcycle. So we know the process lead time will be at least 30 minutes. The question is, how much longer will it take for these 4 subassemblies to complete as well? And it's not clear because of the way the stamping machine is shared between subassemblies 2 and 3, and the welding machine shared across subassemblies 1 and 2, how long this is going to take. So what we have is a scheduling dilemma that we don't understand yet, and until we understand the scheduling, we can't understand the lead time. Most instances, this is easier to diagnose, but in this is a complicated case. It turns out that to understand this, we need something called a Gantt chart. So the Gantt chart, go to the next tab, what we're going to do is resource by resource, we're going to show on a timeline, here time in minutes, we're going to show when each resource is busy. So we know the molding machine, for example, can start at the beginning, and the molding machine is going to take 2 minutes. And I'll just indicate here that it's, I'll leave it like that. And when the molding machine finishes in subassembly 1, the welding machine can begin in subassembly 1, and it takes 1 minute there. So let me note that this is subassembly 1, and this is subassembly 1. When the welding machine finishes in subassembly 1, the engine assembler can begin. That needs 3 minutes, and that's again subassembly 1. So now in my Gantt chart, I see the time sequence of subassembly 1. I can see that it requires 6 minutes, 2 plus 1 plus 3 minutes. But now, when could the second subassembly begin? Well, the second subassembly begins with the 10,000-pound press at stamping. That takes 1 minute. And then subassembly 2 needs the welder. However, the welder will not be free for 3 continuous minutes as needed until the 4th minute. So this is when subassembly 2 can start for 3 minutes. Let's put some boxes here to make it easier to see, to delineate the steps. Okay, so now we see when the stamping machine will be busy with the second subassembly. When it finishes there, the stamping operation can begin at the 2nd minute with subassembly 3. That's a 2-minute operation, taking it minute 2 and minute 3. And then we also need the seat assembly. There are 2 seat assemblers. I've noted them here in my Gantt chart, but I only need one of them to produce the first motorcycle. So I'm going to assume seat assembler number 1 starts on minute 1, will work for 7 minutes. That is denoted subassembly 4. And I'll put it in a box. So, as you can see, here is a feasible set of assignments for subassembly 1, subassembly 2, and subassembly 3, and subassembly 4 to be done. All 4 subassemblies will be done by the 7th minute, at which part the first final assembler can inherit these parts. Then that person will require 30 minutes, starting in minute number 8, going 1, 2, 3, 4, 5, 6, blah, 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 out through minute number 37. That is final assembly. And so we see that The first motorcycle can be built in 37 minutes. The question arises, though, when would the second motorcycle begin? So something that you might find fun is to repeat this exercise. Now let's lay in the second motorcycle and the third motorcycle and the fourth motorcycle. When do various people go into action? If we click on this tab, I've done that, where the green is the production of the first motorcycle. This tannish beige is the production of the second motorcycle. Baby blue is the third motorcycle. Yellow is the fourth motorcycle. And I haven't shown any other motorcycles. But what you notice, which you might find interesting, is that we said the welder was the bottleneck. And sure enough, if you look here, you'll notice that the schedule requires that the welder, once it gets the parts in subassembly 1 and starts working, it can be scheduled and be continuously operating then for the rest of the day. Something else that's not a bottleneck, say the engine assembler, you'll notice will work on subassembly 1, then have a 1-minute break, work on subassembly, the second motorcycle, have a 1-minute break, work on the third motorcycle, break, and so forth. And so it's through the Gantt chart that we can actually see the schedule that makes the lead time possible. The answer is 37 minutes.